MicroPython versus CircuitPython.
In this tutorial, we'll explore the differences and similarities between MicroPython and CircuitPython, two Python implementations for microcontrollers. As developers working with embedded systems, understanding which platform is right for your project is crucial. Here's what we'll cover.
What are MicroPython and CircuitPython?
MicroPython is a lean implementation of Python 3 designed to run on microcontrollers and in constrained environments. Created by Damien George in 2013, it provides a subset of Python language features optimized for hardware with limited resources. CircuitPython is a fork of MicroPython developed by Adafruit Industries. It's designed to be more accessible for beginners and provides enhanced compatibility with Adafruit's hardware ecosystem. Let's see a simple Hello World example in both. MicroPython. CircuitPython. Both implementations use standard Python syntax, which is one of their key advantages. If you know Python, you already know much of what you need to program these microcontrollers.
How do you set up and install each system?
MicroPython typically requires downloading a firmware specific to your board and flashing it using tools like stool for ESP boards. Here's how you might flash MicroPython to an ESP32. This code first installs the stool utility, then erases the existing flash on the board, and finally writes the MicroPython firmware to the specified address in flash memory. The baud rate of 460,800 controls the speed of data transfer. CircuitPython installation is typically simpler, especially on Adafruit boards. Most Adafruit boards come with a bootloader that appears as a USB drive when you connect the board. This installation process is more user-friendly as it doesn't require command line tools. You simply drag and drop the firmware file onto a USB drive that appears when the board is connected in bootloader mode.
Which hardware platforms are supported?
MicroPython supports a wide range of hardware, including the following. STM32 microcontrollers, Piboard, Raspberry Pi Pico, many other ARM Cortex-M based boards, CircuitPython focuses primarily on the following: out of its own hardware, Circuit Playground, Feather, etc. Raspberry Pi Pico, Nordic NRF52 boards, SCMD21 and SCMD51 boards. CircuitPython provides robust drivers specifically for Adafruit sensors and peripherals, making it ideal if you're working within that ecosystem. Let's see how to identify your board in each system. MicroPython. In MicroPython, this code uses the sys module to identify the Python implementation details and the machine module to access hardware-specific information, like the CPU frequency. CircuitPython. In CircuitPython, we use the microcontroller module, which provides similar information, but with a different API structure.
How do library support and ecosystems compare?
MicroPython has a more minimalist approach to libraries. It includes a subset of the standard Python library and provides hardware-specific modules like machine for GPIO, I2C, SPI, etc. Example of blinking an LED in MicroPython. This code imports the pin class from the machine module, MicroPython's hardware interface, and creates a pin object connected to GPIO pin 2 in output mode. Then it enters a loop that turns the LED on and off with half-second intervals. CircuitPython comes with a more beginner-friendly set of libraries and often includes drivers for popular sensors out of the box. It uses the board module to provide pin definitions that match the silkscreen labels on Adafruit boards. The same LED blinking example in CircuitPython. CircuitPython's approach is more explicit, with the Digitalio module specifically for digital GPIO operations. The board module provides pin constants that match physical board labels, like D13, making the code more intuitive for beginners.
How do code development and workflows differ?
MicroPython typically uses tools like Ampy, Rochelle, or dedicated IDEs like Thonny or UPyCraft for file transfer and REPL access. Using Ampy to upload a file. This code installs the Ampy tool and then uploads a file named main.py to the MicroPython board connected to the USB 0 port. This file will run automatically when the board boots. CircuitPython boards appear as a USB drive when connected, allowing you to simply edit files directly. This workflow is much more approachable for beginners as it doesn't require specialized tools. You can edit your code with any text editor, save it, and the code runs immediately. The board automatically restarts when it detects changes to the code file.
What performance differences exist?
MicroPython generally offers better performance due to its leaner code base and fewer abstraction layers. It's designed with performance in mind for resource-constrained environments. Here's a simple benchmark you can run on both. This code defines a simple benchmark function that computes the sum of integers from 0 to 99,999 and measures how long it takes. By running this on both platforms with the same hardware, you can see performance differences. Generally, MicroPython will complete this task faster than CircuitPython. CircuitPython prioritizes ease of use and compatibility over raw performance. While it's fast enough for many projects, it may not be suitable for applications requiring maximum performance.
How do community and support compare?
MicroPython has a large, global community and is extensively documented on its official website. It has a more technical focus and a wider variety of use cases across industrial and hobby projects. CircuitPython has a very active and beginner-friendly community centered around Adafruit. The documentation is excellent, with many tutorials and examples that focus on specific hardware.
When should you use MicroPython versus CircuitPython?
Let's compare approaches to a more complex project. Reading from an I2C sensor. MicroPython. This MicroPython code initializes I2C communication with specific pins, then directly controls the I2C bus to communicate with the sensor. It shows the lower-level hardware control typical of MicroPython. The code directly addresses registers and manipulates bytes from the sensor. CircuitPython. The CircuitPython example showcases its driver-based approach. Instead of handling low-level I2C operations, we use a pre-built library that abstracts all the complexity. This code is much more concise and easier to understand, which is characteristic of CircuitPython's approach.
Key points to remember.
You need maximum performance. You're working with non-Adafruit hardware. You prefer more low-level control. You're developing commercial or industrial applications. You're a beginner or teaching others. You're using Adafruit hardware. You value ease of use over performance. You want a simple drag-and-drop workflow. Thanks for watching.